Hello everyone, today we are going to talk about the Flux tools, the latest release of Flux where they have a few tools released together in the models on Hugging Face. We have talked about the Redux for IP adapter like image style transfer, and we have the Flux Fill where it is doing the inpainting and outpainting models. We also have two ControlNet models which are the depth map and the canny. It is developed by Black Forest Lab, and today we are going to check out the Flux 1 Fill model for inpainting and outpainting. Let's check it out. Here's the workflow for outpainting where you see a very typical text-to-image workflow. Here we have a load image where it is referenced for the outpainting image. As you can see, this path image is for outpainting. This is a new node that is specified for outpaint jobs that you are using for expanding the image canvas by enlarging the pixel size from the left, top, right, and bottom. We will be adjusting the different lengths for the mask area. For example, I have a picture of Bruce Lee, and it will be center of the mask and will expand 400 pixels left, 400 right, and 400 bottom for the outpainting area. Then it will bring the mask and the image data to the InPaint models conditioning where we are going to use. Here's the main part, which is the Flux 1 Fill Dev Safe Tensor files. These files are the inpainting model files for Flux, where, of course, if you are not using inpainting and outpainting, usually we use the load diffusions model. We select the Flux dev model files here, but in this case, we are using inpainting and outpainting, so we are going to choose the Flux 1 Fill Dev file, and these files are available to download right now in Hugging Face, where I will provide the link in the description below. Here you have to click the Files tab and you will be downloading this 23 gigabyte file. If you don't have the VAE of the model files, I suppose all you guys using Flux will have that. Download it if you don't have it and fix it. So back to the ComfyUI layout. Here we see that after we load the diffusion model, we pass to the differentiate diffusions. These custom nodes I have talked about in previous videos about how we can use different conditioning and different inpainting jobs that even enabled you to take effect in Animate Diff for the AI animations back then, and right now in Flux. We are also using the same concept for the inpainting jobs and using the differentiate diffusions nodes here. We will be enabling different noises injected into our existing image. So pass to the inpainting model conditioning. We have the positive, negative prompts like what we typically do. And then we have the VAE that I just mentioned in the Hugging Face page. You can download this one. The one that I have is the short-term extension files where I have downloaded since the Flux release. Although the extension is a little bit different, it's the same files there. As you can see in the text prompts here, I have just typed some descriptive text about the outpainting area where I want to appear, what kind of image that I want to generate. For example, a beautiful scenery of movie scenes in a classical Bruce Lee movie. Right here, I am again using the outpainting. Because this image of Bruce Lee is only a close-up shot of him, I want to expand the area where I can show the other part of his body and then other parts of the backgrounds as well. Let's say this is from the movie Way of the Dragon. That is more specifically what kind of scene I want to create. Typical case sampler we pass for the positive-negative latent image, and then we will use generating all this in the image output for the VAE decode. There we will have the result here. Here's the image that is generated, also very similar to the one that I just showed in the video's intro, where you see actually the skin. Everything is very integrated with the outpainting area, where you see right here, first of all, we got some white borderline in the old photos from Bruce Lee. We have used the outpaint custom nodes, and then we have generated a mask of the outpaint area, which is the white area you see in here. Afterward, we have the outpainting jobs. But one thing I don't know why, maybe my these seed numbers got some problems. There's some broken line in here. Maybe we can try other seed numbers and generate again. But overall, for the top part, it looks pretty nice. And after generate again. And there you go. We have fixed the issues of those blurry things that couldn't be generated from the image. After that, it looks very nice from the original image where you see the shoulder starting from here and the outpainting area. You can even see the bicep on this part, which wasn't shown in the source image. Everything created from here is very integrated into natural styles of the image. You don't see any broken parts like from some other outpainting methods that we used in previous stable diffusion or any other methods for outpainting. The background looks like it's from Way of the Dragon in Rome, where we got some old buildings, but it's kind of blurry. It's also simulating from the original source image. That is excellent inpainting and outpainting from the Flux models. The other thing I want to show is the inpainting jobs using the Flux Inpaint models, the Flux Fill models, where we use for inpainting. In this case, if we're using inpainting, we'll be using the mask editor. Right-click on the load image, click Open in Mask Editor, start painting the area that you want to inpaint, and click Save. We will have this gray area where new elements will appear from what we do in the image generation. This time, we don't need to use the path image outpainting nodes. The image and the mask area will directly connect to the inpaint model conditioning. Passing these two in here, we will be doing the same method as the outpainting method we just did for the rest of the workflow. So differentiate diffusions. Again, the same thing goes to the load diffusions model. Right here, as you can see in the Flux guidance, I see that the default value is set to guidance 30. At this moment, we'll just stay where it is using guidance 30, and you can try testing with other values in here to see what gives better results for your image. So far, I see that these models do a very good job in inpainting and outpainting. It's very stunning. For this image, I have painted this area so the woman won't be lonely standing in this cyber-futuristic tunnel. She'll have another partner standing beside her, which I have put as the Joker from the Batman movies standing in a pose. There you go, we got the generated result. We have Joker standing with the lady so she's not going to be lonely. The output of this image is pretty nice for realistic style images where you see different layers. The AI is able to do very detailed work in the inpainting job. You can even see from this part where I did the inpainting mask, some part of the lady's shoulders are covered here. The AI is able to identify right in this part, this boundary where it shows that the lady is in the foreground of the image. Joker is standing in the background of the image where you see different layering, unlike some cases back then in other inpainting models where you might see two characters integrated together if we do the inpainting mask like this case. Sometimes even the lady's arms would disappear in this part, and it would be like two bodies stuck together into one, or something like that would appear. But I just generated once with this image and got this result already. I think it's very decent output. It's also able to maintain all the details from my original image. Even the border of the character here and the color from the background remain the same. So these models did a very good job in inpainting and outpainting. There's no doubt about that. Let's also try this robot sitting on this rocket device. I have inpainted this area behind the robot, and I have put the ComfyUI girls. If you guys know who the ComfyUI girls are, you'll know that the anime girl has robot rabbit-style ears on top. The cartoon girl is going to be sitting behind this robot in the generated result. Let's check it out. So we got the result here. The anime ComfyUI girl with the bunny ears appears behind the robot. This AI is very smart, able to identify the positions and how the inpainting character is going to be sitting on top of this rocket. Again, compared with some other previous inpainting models, if you had just put an inpaint mask like this, it would take 5 or 6 tries to get lucky with one image that would have good positioning like this. But for this image, I just generated once with proper text prompts to identify what kind of element I wanted to use for the inpaint area. And it just helped me create scenes where the inpaint area is very integrated with the original image as a whole. It looks amazing. This model is able to understand the structure of this image first and foremost. Then it identifies what will possibly be appropriate for the pose of the character or any objects I want to appear in this inpaint mask area. Based on that, It renders very nicely. Although the pixels aren't large size since my original image isn't high definition, you can see it's still able to generate the character sitting on this rocket device where you see some shadow of the legs and shapes like that. And it's able to create all these detailed things as a whole image. I want to show another example where I have a girl sitting at a train station. This image was supposed to be just in portrait ratio. So the source image is very narrow. You don't have any left or right sides of the image. What I did was use the outpaint nodes, creating extra masks on the left and right sides of this image. Then I used a prompt that specified lady sitting on the train station. Therefore, I got this image, and we have the train coming. That's basically it for the inpainting and outpainting method. It's very simple. I think a lot of people have used ComfyUI for inpainting and outpainting. You've used the inpaint model conditioning before and the differentiate diffusions before. But now we have this new node for outpainting, where it creates extra space from the original image to fill the mask on the outside. This is the outpainting job using Flux Fill. Although this is a very large file size model, I think it's worth keeping in the ComfyUI system because it's just way better than other in-painting models on the market right now. Here's another example where I have this image. If you check out my tutorials, you always see this image as a demo for fashion styles or human portrait styles. I've done outpainting this time for the whole image, expanding the view of this urban street. The AI girl here, where I generated the legs with beautiful leather boots. That outpainting result looks amazing. The outpainting from the street here. Let's generate one more time and see it in ComfyUI side by side. Here's the result I regenerated in ComfyUI, and as you can see, we have a side-by-side comparison of both images. The image here is very integrated between the borderline of the original source image where we created the fill area on the side, the wall on the right side, and the legs on the bottom part of the image. All external extra created outpainting jobs. That's very awesome. You don't see any different colorations or skin tones looking different in these image generations. After that, I think this is a very good in-painting model. These in-painting AI models from Flux, and of course this is from their own company creating these models, I have no doubt this is going to be good. Just like Redux that's doing IP adapter-like models that we tested last week, they are doing awesome. Try this out if you haven't yet. This is the Flux Fill diffusion model for in-paint and outpainting jobs. In the next videos, I'll be trying using these models for in-painting and using Redux to do in-painting jobs. There will be mix and match with the Flux tools, the new release tools we have available online, and we'll try using some mix and match with those tools together integrated in one workflow. Also, for the ControlNet models, I've tried using the LoRA ControlNet. Actually, you can download that. Just to briefly mention this one, Canny LoRA models at 1.2 gigabytes and the depth LoRA models. These two methods using LoRA to load the ControlNet happen back in Stable Diffusion, called the LoRA ControlNet, and now it's applying with Flux. The difference compared to the full versions of ControlNet, where you have to download the full versions from Hugging Face again, is they're using the Models Diffusions loader to load this full version of Canny ControlNet at 23 gigabytes file size. I'm not going to opt in for a ControlNet that costs that much file size. Second, I don't think, or I'm not sure, if it's necessary to use the model data weights to become the ControlNet models. For the workflow creations later on, if we have multiple things going on with the Flux models, it won't be flexible for loading other diffusion models in the UNet loader, or what we now call the Load Diffusions model loader. So I decided to opt for the LoRa loader to load the ControlNet. Right here, we have the Flux Canny LoRa, and using this LoRa is very similar to loading LoRa connections. Just connect the models and connect the clips. You see all the same color, yellow lines and purple lines. Just connect them and go to the output here, which is models, and then you have the clip text, clip, and text clip here. That's how you activate the LoRa ControlNet in Flux. One thing you have to add for the Flux LoRA ControlNet is the new node called Instruct Pixel to Pixel Conditioning. This is like the Apply ControlNet custom nodes we use to run with. Right here is where we'll apply the ControlNet for these Flux LoRA models, where you connect the positive condition and pass out the output area here, and also the negative prompts or conditions to the negative case sampler or Inpaint model condition. You can do that here. Let's set up a quick one. For example, we're not doing Inpainting. We need this instruct pixel to pixel condition. We set the low VAE and pass to the red dot here. Then the latent data will pass to the latent image. Just like what we typically do, create an empty latent or the VAE encode past the latent data, the same concept. Afterward, for the pixels, this is the part we have to focus on. We're not going to use the outpaint or the mask. Instead, we're going to use the image. Then we'll use the preprocessors for ControlNet and pass the output image using the preprocessor. For example, in this one we're using Canny, so we'll select the Canny Edge preprocessor. We can even see the output preview image here. Lastly, we'll connect the output image data to the instruct pixel to pixel conditioning in the pixels data here. This will pass the Canny ControlNet mapped image pixel to this pixel data, and it will start processing using this image as a reference. Let's try this out quickly to see how it works. Remember, here, we're not going to use the Flux Fill. Instead, we'll go back to a normal Flux DG V-diffusions model. These are the basic connections. I can't say these are absolutely the right connections because sometimes we might have a few control nets to connect or several different conditionings to connect between in more complex workflows. Let's try this one first and check how it looks. Here's the first generated result using the Canny preprocessors. As you can see, we have the trace line of the original source image where we have the shape of the character's clothing outfit. Then we got the generated result here. The dimensions will use the same as the source image using this connection method by connecting the image into the instruct pixel to pixels condition where we got the latent data that's going to be the same resolution as the source image. If you're using the Flux ControlNet and your source image, like this one, is a small size resolution, we'll need another step for upscaling to enhance the generated result. I tested that before recording this video. I can see the strength of models in the LoRA nodes here is like the typical ControlNet nodes where we apply the strength. We have 0.7 here. It will take 70% of what we have in the instruct pixels and won't be exactly the same shape and form as the source image. The overall size and image structure objects will be almost the same, but as you can see in the generated result, we're not leaning on the wall on the street. Instead, we have the same shape or form of this character, but we have an almost totally different outfit. Some things won't follow exactly the same structures as the source image. Of course, we dialed that down to 70%, and even if we dial it down more to 50%, so in this case we're doing 0.5, we'll have another style of image. Here's the generated result using 0.5. As you can see with the LoRA using 0.5 model strength, it doesn't influence too much. Only 50% of the image from our source reference pixel and structure remains. Well, it will have the character in the middle and standing on the street because that's the basic stuff from the source image. But then, the overall character pose and standing will be totally different. It's not going to look exactly the same because we're using only 50% from the source image. Maybe we can dial that back up to 0.8. That's going to be the sweet spot, leaving 20% for AI creativity. Let's see how that runs. There we have another image using 80% of the Canny preprocessor image where some lines are following the reference image. But then we got different looking outfits. We have the wall as the background structure as well, the same as the reference image. Here we got about 20% of the background on the side of the row, where this generated result also follows the same composition as our source image. So this is again a very quick way to demonstrate how to use the Flux LoRA ControlNet. This is how it goes. Same thing with the Flux ControlNet models. But this file size is too large. I suppose that will be just like the diagram in these examples here where it's using the ControlNet in the load diffusions model custom nodes. Basically, that will be using not the LoRA, and if we download that full size of the ControlNet models, that will be changing in the Flux models here to run that ControlNet. But I think that way won't be flexible at all if we develop the workflow further. Most of the time, I'll need the original Flux models as the load diffusions models and pass to many other groups for loading up the data there. So I think the LoRa loader here is lightweight to download and also flexible for us. Maybe we have another group where we don't need the canny control net, then we can change that in other workflows of the group as well. Those are my conclusions on using the control net in the Flux Tools latest release models. That's it for this video. I'll see you guys on the next one. Have a nice day. See ya.